and gentlemen,
boys and girls, we are from Keller University Lakeside,
studying in Foundation Engineering Sem 2.
and we are
Two Mosquitoes!
Okay, I'm William.
And I'm Matthew.
Today, we were given a task which we are given a container to be analyzed.
And we have to determine the new dimension of this replacement container, which requires least amount of material, and to identify the most economical way for a closer packaging.
Yes.
Thank you. Like we said just now, this is the container given. Assume that the volume of the container given is A and the price or cost is B. So how can we use different dimension of container? Which means same shape, different dimension, or use different shape, but we can get the least amount of material. We can use the least amount of material, can get the lowest cost, but we can still get the same volume. So this is what we're going to do later. Same shape, same volume, different cost. Different shape, same volume, different cost. Different shape again, same volume and different cost.
We were given a cylinder which is volume A, and today we will, as you all know, every cylinder may have the same volume but different surface area, which means the heights may vary. So as the height may vary and the surface area may vary, so the price will also be different. So today our objective is to find the lowest cost. We have to use the least area that is needed, which we can find it based on the graph. As for instance, a cylinder shape has a volume of pi r square h, and we can change it to the height equals to the volume which is given, because we are using the same volume, so we can put it here, and then it's over pi r square, and the total surface area of it will be pi r square times 2, because there's two circles over here, and 2 pi r h, which 2 pi r is the circumference of the circle, and the height is this one. As when we remove it, it's a rectangular shape, and so okay. So if we want to find the cost, we can use this, because our cost is given by measuring in area. So we use pi r square times 2 times cost plus 2 pi r h equals to the total cost. So if we put it in a formula like this, it's pi r squared times 2 plus 2 pi r multiplied by the h. We get it from here, and we can put it here as the height is the same for this case, equals to v over pi r square. So we can cross out this r and r square, and then we can use this equation and put on a graph where r is the radius, and for the y-axis, it will be the total cost. So our objective now is to find the minimum point which we can find the least amount spent, which is also the least cost, and we can find that least cost. And when we obtain the minimum point, we can find the least amount spent in that particular radius.
Like what you said just now, this is cylinder given. Okay, so we're giving the radius equal to 0.025 meter and the height equal to 0.15 meter. To find the volume of the cylinder, we use the formula pi r square height. Substitute the value inside, we get 9.175 times 10 power 85 height, or 2.95 times 10 power 84 meters square. So given the top and the bottom to the height, they 2 ringgit each, side equal to 5 ringgit each. So like what my friend did just now, we open it, so it becomes 2 circle, top and bottom, at a rectangular side. So to find the area for the circle, we use pi r square. To find rectangle, 2 pi r times h. So substitute the value, same substitute the value. The price of the cylinder we get is 0.72 cents.
For this cylinder, we have to use 72 cents. But now I want to create a new cylinder which has the same volume but different height and different radius, so that I can save more cost. So therefore, we use a new pi r square h, but it's the same volume. So the equation can be written like this. Then we use, so as we all know, the total surface area for this one is 2 circle plus rectangular equals to total area. So it's 32, which is cost of top and the bottom, times 2 pi r square plus 25, which is the side area of course, plus 2 times 2 pi r h equals to the total area, which is 64 pi r square plus 50 pi h, which can be sub using this equation below, so that we can get one unknown, which is easier for the future doings. Okay, now we have to find the minimum point so that we can find the minimum cost for the radius, which is, so we differentiate it, so it's 1 to add pi r minus 50 pi over bracket 9.175 times 10 to the power of negative 5 over r square bracket, which when it's minimum radius dA over dr equals to 0, which is also to 1 to add pi r equals to 50 pi bracket 9.175 times 10 to the power of negative 5 over r square bracket. So it's when you put r square into here and move everything except r to the other side. So it's r cubed equals to 3.6621 times 10 to the power of negative 5, which then we can find r equals to 0.0332. Then we sub r into this equation, which we can get h equals to 0.05054. So now I am able to find the new price, which is 64 pi, using the same formula as mentioned before here. 64 pi times 0.03232 square plus 50 pi times 0.0332 bracket 0.05054. So now the price will be cheaper. It's 66 cents. That's all. Most assumptions we can make after we improve our design is we can save costs, as mentioned in previous before. We can use less material, as the area of it will be smaller, and also the maximum, we can maximize the usage of the space. For example, when we have 4 cylinders, and when you're putting in the box, you can fit more cylinders in the box compared to the other one. And last but not least, this one is the old design of the cylinder, which is 0.025, and the height is 0.15. So this one is the radius, and the radius for this one is 0.0332, and this one is 0.08 for the height. And as you can see, this one it's like dividing two, but then the radius, it's only affect a few, and it's better in when you are selling this product. People would want to buy this more, as it looks more smaller looking, and also people will assume that the volume will be smaller. So then,
New question. In this question, we are doing 12 cylinder. How can we arrange the 12 cylinder in different arrangement, and we can get the least total surface area, and the cylinder given is with the same volume and the same size. Okay, so we are going to arrange them in 3 different ways. First is 3 times 4, 2 times 6, 4 times 3. So for the total surface area for 3 times 4, we get 0.0565. 2 times 6, 0.0848, and 4 times 3, 0.0428. So we can confirm that the total surface area for 4 times 3 is the lowest. If we arrange the cylinder in this form, we can get the lowest total surface area,
which is also the lowest cost.
Throughout the entire assignment, we are able to use calculus in our daily life, which can be used in our future jobs, and we can save lots of time, make lots of money using this application.